Okay, so for lesson 15, dandy discounts. This problem here kind of goes right back to one of the problems we were looking at in lesson 14. And so we have a 25% off books at a bookstore. Okay, so we have an original price of $32. All right, so we have $32. That's our original price. Okay, then we have another discount for 25. Okay. If there was no sales tax, how much did Priya pay for the books? Sorry, for the book. Ugh. All right. How much did she pay? Okay, so the 25% off tells us how much was removed, okay, from the $32. It doesn't tell us how much she paid, okay? So what we're going to do is we're going to take this and we're going to multiply it by 0.75. Okay, so that's how much is going to be paid for the book. Okay, but then another 25% was taken off. Okay, and so we're going to set the problem up like this. So here's our first 25% off. Here's our second 25% off, and then we do this. We're going to get $18. Okay, so let's take a look at the next one. Owing interests. To get a new computer, a recent college graduate obtains a loan of $450. She agrees to pay 18% annual interest, which will apply to any money she owes. She makes no payments during the first year. Okay. So we have $450 and we have an 18% annual interest. Okay. So how much will she owe at the end of 1 year? Let's take a look at that. So what we're going to do here is we're going to take our 450 okay, and not making any payments. So what's going to happen is we're going to have 1.18. Okay, so remember the 450, right? The 1 here accounts for that 450. And then the 18 here accounts for the 18% interest rate. So what we're going to have is $531. Okay, so at the end of 2, okay, we're going to have the 531. Okay, then we're going to multiply that by 1.18 for another year that's passed and no payments have been made. Okay, and that's going to be, let's see, 626.58. Okay, and then what we have to do next is we're going to take, for our third year, we're going to take that number 626.58, right? We're going to multiply that by 1.18, and we're going to get, let's see, about $739.36. Okay, so that's our third year. Here's our second year, and here's our first year. All right, to find the amount owed, okay, at the end of the third year, a student started by writing year 3 amount equals year 2 amount plus year 2 amount times 0.18. Okay, so this would be the equation. Does your final expression correctly reflect the amount owed at the end of the third year? Okay, and then explain or show your reasoning for this one. Okay, so what we're going to do here, let's see, after a year, okay, is 450 plus 150 times 0.18. Okay, or we can write it as 450 times 1.18. Okay, after 2, let's do after 2 years, okay, we have 450 times 1.18 plus 50 times 1.18. Okay, and that's times 0.18. Okay, so what we can do now is we can factor out the 450 times 1.18. Okay, so we're going to factor that out of the equation. Okay, we're going to have 450 times 1.18 times plus 0.18, okay? Or we can write it as 450 times 1.18 times 1.18. Okay, and so now this is our first year, our second year. So our third year, okay, what we're going to do is we're going to have 450, right, times 1.18 first year, 1.18 second year, third year, 1.18. Okay, so yes, okay, it does work. Write an expression for the amount she owes at the end of X years. Okay, so we have 450, okay, so that's the start, times 1.18, which is our factor, and then we have X for the number of years. Okay, so similar to questions that we've looked at before. Okay, let's see here if we're going to do this one. Okay, so what we have here is if we have, let's see, we're going to take the middle third of the line segment and we're going to replace it with 2 line segments. Okay, then we're going to repeat it over and over. So if we look at the second piece, okay, so we have our second piece. Then what we're going to do is we're going to start with line line segment length of 1/3 and replace it with two line segments with length of 1/3. So the new length is 1 minus 1/3, okay, plus our 2/3, okay, so it's here and here, is equal to 4/3. Okay, and so if we have, let's see, the length at any stage, okay, then the next stage we have removed 1/3 1/3 of p. Okay, and this is like too small. I'm going to come over here. 1/3 of p, and replaced it with new segments of 2/3 of p. Okay, so for any step, we're going to have p minus p over 3 plus 2p over 3 is equal to 4/3 p. Okay, and so we pick up a factor of 4/3 every time. Okay, and so what this means is we have 4/3 the n. Okay, where n is how many times we do this replacement. Okay, so I'll give you a second just to copy that down. Okay, sorry it's so messy. Again, let me just read it. Our second piece. So start with a line segment length of 1/3 and replace it with two line segments with length of 1/3. Okay, so that's what we did right here. So the new length is 1, okay, minus this 1/3. Okay, so it's going to be the whole 1 minus the 1/3 that we took here. Okay, and then we're going to replace it with two line segments with length of 1/3. Okay, so this is 1/3, this is 1/3. Okay, so the new length is 1 minus our 1/3 plus 2/3. Okay, so we add the 2/3. That gives us a total of 4/3. All right, and so that's how we set up our equation and get this down here. Okay, let's look at the next one. And I'm going to erase what is up here just so that we can read it a little bit better. Okay, so we have 3 people who have taken out loans for $1,000. Okay, loans so that they're going to have interest to pay back on that. But they each pay different annual interest rates. For each loan, write an expression using only multiplication for the amount owed at the end of each year if no payments are made. Okay, so we've kind of seen this before. So I'm going to just write this down really quick. So we'll do the 1,000. Okay, and then remember to see how much is going to be owed at the end of 1 year. We're going to multiply it by 1 point and then the interest rate right there. Okay, so then remember we're going to just keep adding 1,000 times 1.12 times 1.12. Okay, and then we're just going to keep adding the 1.12. Okay, so let me just go ahead and complete this table, and then we'll move on. Okay, so here we can see how things work. Okay, we've looked at this previously, and so we're going to have our interest rate, okay, which is right here. And then for every year, that's going to be our x. Okay. Second one, use graphing technology to plot the graphs, and then based on your graph, about how many years would it take for the original unpaid balance of each loan to double? Okay, so use Desmos or GeoGebra to plot those equations. Okay, and then when we do that, we're going to get something that looks like the graph down here. Okay, and then based on your graph, about how many years would it take for the original unpaid balance of each loan to double? Okay, so what we can do is we can take, let's draw a line here, and we start at 1,000. Okay, so we're starting here, okay, and then we're going to double. Okay, so that's going to be 2,000. So right there is about 2,000. All right, and so then what we're going to do to double, okay, we've got, let's see, zoom in a little bit. All right, so for C, let's see here. Okay, we're looking here. All right, and that's going to be about 3 years. Okay, for B, B is blue. Okay, so for B, we're going to look where it crosses. Here. Okay, and that's going to be about 7.5. Okay, and then we've got A, which is just about here. Okay, and so we're looking at about 6 years or so, or 6.25 years, just around there. Okay, so that is how we're going to approach that problem with graphing. Okay, And you can get a little bit more precise when you go into the graphing technology. All right, let's look at the next one. Okay, for this one, you're also going to need some graphing technology. And then that will allow you to basically see what is happening. And you can zoom in and get a little bit more precise. But what I'm going to do is go ahead and put the answers here just so you can double check your work. Okay, so here are the answers that you should get for those questions. Okay, and then this is important here. How do the average rates of change for the three loans compare in each of the 2-year intervals? All right, so the average rate of change for all three loans is greater from the end of the 10th year to the end of the 12th. But while loan A is 3 times greater, loan B is almost 9 times greater, and loan C is over 14 times greater. Okay, so this is going to show you the effect of compounding interest over time. Okay, so basically when we look at our loans, okay, of 12%, 24%, and 30%, we can see how quickly or how different these rates of change or interest rates impact our rate of change and how much we're going to owe. But the good thing is, okay, this works for savings as well. Okay, so if you have $1,000 and you can invest it in something that earns you 12% interest, which is really, really hard to find, if at all, you're going to have that amount of money. Okay, so it can be good or bad depending on if you have a loan or if you're able to invest something. All right, so again, take a look at our summary. It'll sum up everything that we covered.